All right, class, so this is going to be for page 38. Make sure to like and subscribe, right? Unit 7-4, modeling with quadratics. So basically, we're going to take all those quadratics that we learned and we're going to apply them to real-life situations. I'm going to go through this as quickly as possible, right? The only ones we didn't get to do in class for most of the classes are the last ones, right? So go ahead and skip to the end if you want to. The cost to install a certain kind of floor tile is $15 per square foot. So the total cost to install tile floor in an x by x foot room is f of x equals 15x squared. How much, right, would it cost to install in a 7 by 7 foot room? Best thing to do, draw a picture. We're modeling after all, right? So this is a really terrible looking square, but it's a 7 by 7 foot square. So how many tiles can we fit in this? Well, each tile is per square foot, right? So that means each tile is only 1 by 1. So to find the area of the entire thing, we would do area equals length times width, right? So 7 times 7, area equals 49. So 49 tiles can fit inside here. I'm trying to figure out the cost to install in a 7 by 7 foot room, and it's $15 per square foot. So it's as simple as 15 times 49, which is going to be 735 when you type it in a calculator. So that's the logical way to do it. The algebraic way to do it, okay, would be to do it like this. And I don't care which way you do as long as you're able to get the answer. We're given an equation, f of x equals 15x squared. Well, I know x by x is x squared, right? So the area of the room is this x squared. How much would it cost to install in a 7 by 7 foot room? Well, let's evaluate when x is equal to 7. So it'd be 15 times 7 squared, which if you notice is the same way as the logical way. X by x room, 7 by 7 foot room, it makes sense that x would be equal to 7. I'm gonna go ahead and put that. So let's keep going. 15 times 49, right, is gonna be 735 again. So I don't care which way you do it, as long as you're able to understand that you're looking for the cost of all the tiles. So you have to do 15, in this situation, $15, right, times the amount of tiles, which in this case is going to be 49. So let's do the next problem with the same logic. This time we can move a little bit faster though. The cost to install certain tile floor is $20 per square foot in an x by x room, so we have the equation 20x squared. How much would it cost to install in a 6 by 6 foot room? So again, let's just do it algebraically. Now we're looking at 20x squared. So let's do 20, and x is going to be equal to 6 because we're in a 6 by 6 foot room right now. So 6 squared. So it would be 20 times 36, which will give me $720. So make sure you guys can do this, right? Go back through it, do them again, check your answers, whatever works for you. Answer key will be on Canvas as well. I'm going to go ahead and keep moving forward. You can pause here if you want to copy, but we're going to keep moving on. So this one is the most classic quadratic equation problem you're going to get. A ball is thrown into the air with an upward velocity of 96 feet per second. Its height, h in feet, after t seconds is given by this equation right here. How long does it take for the ball to reach its maximum height? And what is the ball's maximum height? So when I'm talking about maximum height of a ball, what I'm asking for is assuming you threw a ball in the air, at how high does it go and what time was it at when it was its highest? So what are you looking for? The vertex. That's it. You're just looking for that vertex point. So to find the vertex, you just follow a few simple steps, right? Well, we're given an equation, so which means I can use x equals opposite of b over 2a to find this value, the axis of symmetry. Then to find the y value, and I have to plug it back in. So let's go ahead and do this. How long does it take the ball to reach its maximum height? Well, I'm looking for the axis of symmetry. I'm looking for the x value, or the t value for time. This is t and h for height, right? So I'm looking for the time that it takes to get to the vertex. So opposite of b is negative 96 divided by 2a, 2 times negative 16. So then we just simplify like normal. Negative 96 will be on the top. 2 times negative 16 is negative 32. We know a negative over a negative is positive. 96 divided by 32, it's going to be positive 3. But remember, we're talking time right now, so it's seconds. This will be a grid response question on the test, so you're just going to put 3. So at 3 seconds, how high was it? Well, let's evaluate when t is equal to 3, what our height is, our h is. So let's find the other value of our vertex, negative 16. Instead of t, it'll be 3 squared, don't forget the squared, plus 96 times 3 plus 6. When there's a question, there's an answer. So let's keep going. If you type all of this in your calculator, or even if you do it individually, you'll get 150 feet. So you guys, I trust that you can type this in a calculator and figure it out. You just do 3 squared times 16, negative, add it to 96 times 3 plus 6. Okay, so number 4 is the exact same situation. We have another ball being thrown in the air, but this time at 48 feet per second. We still are starting at 6 feet, which is our starting value, and now our a value is negative 8. So instead of it being going up really, really thin, it's going to take a lot longer to get down, right? And it's also probably not going to go as high because we're not throwing it as fast. So we're still starting at 6 feet. I didn't actually mention that in the other one. 6 feet is our starting value, by the way. But why, you ask? Because it's our c, it's our y-intercept. So this being negative 8, all right, it would make sense that this one would go a lot higher, a lot faster. This one's going to be a little longer, right? So it might not go as high. So let's figure this one out. How long does it take for the ball to reach its maximum height? Again, long means time, right? We're looking for t. So we're trying to find the t value of our vertex, which is also the highest point that it reaches, h and t, right? So let's find a, b, c. Let's log it in. Opposite of 48 is negative 48. 2 times negative 8. This will be negative 48 over negative 16. Negative 48 divided by negative 16. Wow, would you look at that? 3 again. Now, trust me, it won't always be 3. I just made these questions to be easy for a reason. If you get a decimal answer, that was totally acceptable because seconds can be measured in decimals as well. So we're at 3 seconds. So at 3 seconds, how high is this this parabola, right? Well, to figure that out, we have to plug it back in. So negative 8 times 3 squared plus 48 times 3 plus 6. So one thing at a time, 3 squared will give you 9. 9 times negative 8 will be negative 72. And then 48 times 3 will be 144 plus 6. You add all this together, you get 78 feet. Classic. Classic problem. So our vertex is at 378. So 3 to the left, or 3 to the right, 78 points up will give us our vertex. So at 3 seconds, it's 78 feet, TH. Okay, so if you have questions about this, let me know in class, but for the most part, we're going to be moving on. Sorry, I was covering that with my finger the whole time. So go ahead and pause the video if you need it. We're going to switch to the back side. So on the back, biologists took account of the number of fish in a lake and recounted the lake's population of fish on each of the next 6 weeks. Which quadratic function models the data as a function of x, the number of weeks? Use the model to estimate the number of fish on the lake at week 15. So this is a 2-part question. We're trying to figure out which one of these multiple choice questions best models the data that we're given, and we also have to evaluate it for week 15 and figure out how many fish there are. Well, let's look. As the weeks go on, what happens to our fish? Well, 495, it goes down a little bit more, then it goes back up, and then it goes back up, and it goes up. Okay. So what we're looking at is population first started to die out a little bit, but then it kept on going and going, all right? So do we see our vertex in here? Well, I mean, one could assume it's right around here, right? Because it starts to go down, then it starts to go back up again, but that's the least interesting part about what I'm looking for. This point 0, 495 is super important. If weeks are x and population is y, input, output, right? We can tell our y-intercept is 0, 495. So this cuts down our answer choices dramatically. Which ones don't have a y-intercept of 495? C and D. That's a 445. So I know that 495 looks really funny. Anyway, so now we have to look at these two equations. Well, good news, guys. They're both exactly the same equation. So all we have left to do is evaluate P for 15 weeks and figure out how many fish there are in 15 weeks, because it's either 1842 or 1365, right? So we'll have 5 times our x value of 15. You will need a calculator for this. Minus 17x plus 495. So this really hard problem was broken down and made a lot simpler just by using the process of elimination and the basic information that we're given. We have a y-intercept. Well, this one is the only one that has the same y-intercept. Let's evaluate. So if you type this all in your calculator, you'll get 15 squared times 5 is 1125 minus, oh, that should not have been an x. My bad, guys. No one told me. Oh yeah, that's right. There's no one in here right now. It's just me. If you're watching this video, let me know tomorrow that you watch this video. You can just say the code word to me, bananas. And if you say bananas to me, I'll give you a treat. How about that? 17 times, oh yeah, or 15, right? Just come up to me and yell bananas. I'll just know. I'll know that you watched it. All right, so 17 times 15 is 225 plus 495. All right, if you add all this together, you'll get 1365. So which makes B the correct answer choice. At 15 weeks with this model equation, we have 1365. Good news, guys, this second equation, the exact same thing, just different answer choices, right? So we still have 0, 495, right? So we're still looking for one that has 495 as a y-intercept. Which ones do? Well, C and B do not, and we're evaluating for week 12 this time. So week 12, we're gonna plug in the exact same thing into our equation. Look, both equations are exactly the same, 5x squared minus 17x plus 495. So 5 times 12 squared minus 17 times 12 plus 495. Type all of this in a calculator, and you should get your final answer of 1,011 fish, which makes A the correct answer choice. So good luck tomorrow on your test. I believe in every single one of you. We're at 12 minutes. Mr. Bales signing out.